Good morning, children. So, now the next part of the topic, methods of finding HCF. What is HCF? Highest common factor. In the previous class, we have seen how to find out the factors and then to check for the common factors, then also highest common factor. Is it not? That is generally like after for determining the factors and all that. Now, the same we are going to do here. There are two methods of finding HCF. One is the prime factorization method and the other is continued division method. So, what are the two methods? Prime factorization method and continued division method. So, there are two methods. So, prime factorization method, already we have seen this. Now, let us see how to find out the HCF. Okay. So here in the example we are taking three numbers 12, 30 and 36. So like for these three numbers, what is the highest common factor? That is what we are going to determine now. So you know already how to find out the factors of this, right? So now take the prime factors of it. So 12, what is the least prime number? 2 is the smallest prime number. So use 2 here. Like 2, how many times it will go? 2, 6 are 12. Then again 2, 2, 3 are 6. Then it won't go in 2. So therefore 3 ones are 3. So till 1 we are going to continue. That we have already learned it, right? So therefore 2 into 2 into 3. So therefore 12 can be written as 2 into 2 into 3. Okay. So similarly let us do for 30. Let us do for 30. Suppose you take the smallest prime number, 2 15s are 30. Then 2 table won't go. Then 3 5s are 15. Now 5 ones are 5. So therefore how are you going to write 30? 30 is equal to 2 into 3 into 5. Right. So now let us do it for 36. We don't have space here. So let me shift here. So 36. 2 18s are 36. Then 2 9s are 18. 2 table won't go. Then we go with the next prime number. 3 3s are 9. 3 1s are 3. So therefore, how are we going to write 36? 36 is equal to 2 into 2 into 3 into 3. So we got we have factorized it, right? Prime factorized it. So now to understand what are the common things that you have. Yes, 2 is common everywhere. 2 is common everywhere. Then is another 2 common? No, another 2 is not common. It is here in 36 as well as in 12, but it is not there in 30. So therefore 1, 2 is common. And now going to 3. Is 3 common? Yes, 3 is common everywhere. So 3 is common. How many 3s are common? Only 1 3 is common. Here you have 2 3s, but here only 1 3 and 1 3. So what is common here? 2 into 3. So 2 into 3 is common. So therefore the highest common factor is 2 into 3, which is equal to 6. So common factors are 2 and 3. Highest common you are asking. So therefore 2 multiplied by 3. Is it here? Yes. 2 multiplied by 3. Is it here? Yes. 2 multiplied by 3. Is it here? So therefore what is the highest common factor? 2 multiplied by 3. Therefore HCF of 12, 30 and 36 is equal to 6. This is how you have to write the answer. Okay, children. So what did we do? We determined we factorized. So prime factorization method we used for all three numbers separately. Then after that we have seen how much is common in everything. So here 2 into 3 is common in everything. So therefore 2 into 3. What is 2 into 3? It is 6. 6 is the HCF. This is prime factorization method. This is prime factorization method. Now let us see continued division method. It is something like your what do we say, long division method. It is something like your long division method, but with some difference in it. How to find out HCF using continued division method. So now we are given, like first example, 56 and 64. What you have to do is, so you have to divide 64. You have to divide 64 with 56. With 56. So how many times it will go? So it is one time. So minus 56 upon subtraction you got 8. So now what to do? Here the remainder is not 0. So until the remainder is 0 you have to go. You have to continue this division. But how? So now you are left here with 8 and this is 56. Now the method here is, now you bring this divisor here. And this 8 will become the divisor. So 8 sevens are 56. 8 sevens are 56 minus remainder is 0 now. What is the remainder here? We got it to be 0. The last divisor. So in this process, whatever is the last divisor, that is going to be the HCF. You have to remember this. Suppose if you are left with 2 as a remainder here, and then again 2 you will take the divisor and this will come into the dividend place. Like that the process continues. But here luckily we stopped it here itself. The last divisor is 8. Therefore HCF of which numbers? 56 and 64 is 8. What is 8? 8 is the last divisor in this process. 8 is the last divisor in this process. Okay, children. So, next we shall see one more example. Which example are we going to see now? 3. If suppose 3 numbers are given to us, as in case of the previous case, here it is 12, 30, 36. Same we will take it here also, 12, 30, 36. In this process, how to determine this particular HCF using which method? Continued division method. Which method we are going to do? Continued division method. So the same process. But see how we are going to do. So first take these two numbers. Smaller numbers. So divide 30 with 12. Right. 12 twos are 24. So minus, we are here with 6. So now the remainder is not 0. So thus what we will do? We will bring this 12 here as a dividend and this is the divisor. 6 how many times it will go? 2 times 12. So remainder is 0. So you are left with last divisor as 6. Last divisor 6. Right? So now we have to continue this third number with this particular 6. Okay, with this last divisor, you are going to divide 36. Now let us see this part. So 36 has to be divided by the last divisor of the previous two numbers. Now 6. So 6 are 36. So 0. We got the remainder to be 0. This itself is the last divisor here. So therefore, what is the HCF? HCF is 6. Therefore, HCF is equal to HCF of 12, 30 and 36 is equal to 6. Okay. So, by which method you did? Continued division method. How did we take? First we have taken the smaller two numbers. The smallest one will be dividing the next number. So, then we will be getting a remainder 0 at the end. Till that you have to continue this. And the last divisor, whatever is left in this two, that will go and divide the final number. What is the last number? 36. So 6 is the 36. In this also this is the last divisor. 6 is the last divisor. Therefore HCF of 12, 30, 36 is 6. Clear, children? Yes, this is how you have to do continued division method as well as a prime factorization method. Now you pause the video. Take the screenshot of the examples first. Take this screenshot. then again this part, then afterwards you can copy this one. Right, children, next let us see one more example under continued division method. Okay, so that it will be clear for you how to do HCF based on continued division method. Okay, so now what are the numbers which are given to us? Here the numbers given are 40, 56 and 60. The numbers given are 40, 56 and 60. What is the condition? First you have to take the smaller numbers. Take the smaller numbers. Solution. So 40 should divide 56. 40 should divide 56. How many times it will go? One time 40. So you are left with 16. You are left with 16. Now what happens? You bring this divisor here as a dividend. Right? 40. So now 16. How many times? 2 times. 32 minus. So 12, 16 2s are 32. Then now it is 8. Now what is the remainder here? 8. It is not 0. What did I say? This process should be continued until we get 0 as the remainder. So what has to be taken? Now this divisor will take the place of the dividend. So now 8 2s are 16. Very good. So therefore now the remainder is 0. What is the last divisor? This is the last divisor. Last divisor is 8. Now what is the next rule? This last divisor must divide the next number, right? That is 60. So now let us see, right? 8 should divide 60. 8 should divide 60. So 7 times. 7 8s are 56 or 8 7s are 56. So what is the remainder here? 4 is the remainder. Until we get a 0 remainder, you have to take the same process. Now this will come here, 8. So now 4 2s are 8. So 0. So what is the last divisor here? So we got 4 to be the last divisor. We got 4 to be the last divisor. See the magic here. Suppose if you have taken only 40 and 56, if you take only these two numbers and you are asked to find out HCF, this last divisor is HCF of both. But we got one more. So 8 is not the divisor of 60, right? 8 cannot be a factor of 60. So what is happening? We have to process and find one common factor, and it should also be the highest common factor. So in this process, what did we get? 4 is the highest common factor of all, for all these three. See here, 4 40s are, 4 10s are 40, is it not? Then 4 14s are, right? Then 4 15s are, see, so 4 is the one which is commonly dividing all these three. So therefore we conclude it as HCF of what and what? 40, 56 and 60 is equal to 4. Which 4? The last divisor of the second part, not of the first part. First part, this is the HCF of only these two numbers. When third number is also taken into account, then the last divisor of the last part will be the HCF. Is that clear, children? Yes. Try your exercise problems after this class, so that if you have any doubts, I can clarify them. Or you want me to take one more problem? Yes, okay, I'll do one thing. I'll take one word problem from your exercise, okay? So before that, please pause the video for a moment and then take the screenshot or copy the notes. So this part and again this part. Okay, children, now exercise 3.4. Let me take a word problem from it. So that's the fifth problem. What is the capacity of the largest vessel which can empty the oil from 3 vessels containing 32 liters, 24 liters and 48 liters, an exact number of times? What is the meaning of it? See, we have 3 vessels, right? What are the 3 vessels? You have the smallest one being 24 liters, right? And the next one is 32 liters and the next one is 48 liters. You have 3 vessels. What he is asking is, so find a particular container, right? So which can measure, right? Which can measure all these in exact divisions, right? All these in exact divisions. Something like that, after measuring 3 times, if some half of it is left over, it doesn't mean that it is dividing, it is able to measure it exactly. Exactly measuring means the number, this is something, the capacity of this should be something like it can divide all the 3 without leaving a remainder. What is the meaning of this? The capacity of this should be the common factor of all these. The capacity of this should be the capacity of this particular vessel should be the common factor of all these things. But what is the twist in the question? He is asking, what is the capacity of the largest vessel possible? Largest means which common factor? It should be highest common factor. So that is the meaning of it. So now what is simply? Simply you have to find out the HCF of 24, 32 and 48. So let us find out the now solution. We will go for solution part now. We'll go for solution part. So what is that? 24. Now HCF of 24, 32 and 48 can be the capacity. Can be the capacity of the vessel. Right? Capacity of the measuring vessel. So therefore you are going to find out the HCF. Therefore, to find HCF, now we are finding HCF. Take the smallest one. The next one is 32. What are the numbers? Numbers are 24, 32 and 48. So now take 32 here. So 24 how many times? 1 time. So what is the thing? 12 minus 4, 8. Is it so? Right. And then comes what? Now the remainder is not 0. Hence what are we doing here? We have to bring the divisor here as a dividend. Now 3 8s are 24. So the remainder is 0. This is the last divisor. Last divisor. This is the last divisor. So what should be done? When third number is given, only when 2 numbers are given. If suppose 2 numbers are only given, then this can be the HCF of both. Right? So, but what is that? We have one more container, that is a 48 liter container is also there. So, therefore, what should we do? We have to take this as a divisor and then 48 as a dividend. So, let us go for the next part. So, 8 should divide now 48. 8 should divide now 48. So, how much is that? 648. 8 6 are 48. 0. So, what is the last divisor? 8 itself. Last divisor is 8 itself. So here we got therefore HCF of, therefore, so the capacity of, we got the HCF to be 8. So therefore the capacity of measuring vessel is equal to 8 liters. So if you take an 8 liter vessel, absolutely it can divide all this. That means it can easily measure completely, exactly all the 3, right? So like see here. So what are that? 32, 24, 48, is it not? So then if you take 8, right? So then what and what? So 3 8s are 24. So 3 times if you can measure this particular vessel, it would be enough. Then 4 times if we measure with the same, it would be enough. 6 times here. So therefore, if you take an 8 liter vessel, it can exactly measure all these, the quantity from all these 3 containers. Is that clear, children? So this is how you have to convert the word problem into pure mathematical problem and solve it. And this is the application of HCF. Why should you know HCF? This is how you should know the HCF. Why you should know the HCF means this kind of applications you will have so many in your day-to-day life. Okay, children? Okay. So now just pause the video for a moment and copy the notes. Then this part. Then again the last part. Then again the last part. Okay? Okay, so please complete your exercise problems post me so that we can proceed to the next topic. Bye bye. See you again.